Every programmer once thought, what if I make a programming language? COFP 29th. What is Interpriterlol? Interpriterlol is a programming language I made that is designed to look dumb, yet Turing complete. Let's jump right in. Hello, it's me, COFP again, and as we've seen here before, as we've seen, we'll be discussing today Interpriterlol. It's a language I made. Now, just let me get quick to slns.org. Interpriterlol, yeah. Weird boy. That's so dumb. And feel dumb, yet they're incomplete. This is a page about Yeti. Yeah. They're incomplete. This is a page about their incompleteness. I get on left. Contents, commands, references, not the right links at the end, but the references in programming. Let's discuss them. Commands. Author's note, I have a Yeti in my business that I can get rid of. It's a joke. But, the Yeti still, redirects to the Yeti. So the commands in Interpriterlol are nothing really special, yet, Yeti, not standard, only for naming conventions. Name, arguments, what it does. Okay, so you need to know, some Python. I can, you see this list, you can substitute it with, no, okay, you don't need to know Python, just, no, well, for this list, if you are not in Python, substitute it for array. Okay. Name, right, value. Value can be a string, a number, a list, or a reference. What it does, it writes out the value into the terminal or wherever you're running this. Your text, yeah. Go to value, number without a fractional part, or with a dot zero. Goes to the line specifies in the value. Note that lines start with 0. Yeah, so the first line is 0. 0th is the 0th line. Get, it takes in a string and just prompts you for something. In case a string, and get num, it takes the same string and prompts you with a number, with this string specified as, like in Python again. Yeah, like in Python. References. This is a huge part. So a reference is a pointer, but high level. So what it basically does is makes a variable be settable by a variable. So for example, if B is a reference to A, denote like reference A to the A, then B would reset A in setting B like this. B equals something. Would set A instead. You need to use this expression tilde equals to reset the value of B. Yeah, variables. So variables are created and set in a Python-like manner. Name equals value. But if you set it to a reference, however, like this, you set to a reference like this. So the name is a reference to a variable, a two-day variable. I'm saying. Any attempt at setting the variable will result in the variable in the reference to be set. So this variable. If you wanted to reset the variable, that's a reference, you need to use this. And also references can be this notation, so indexes of a list, yeah? And they can also be indexes, and by default, not like in Python, they are just separate. So if you set name to a variable, it will be set to the variable's value. It will set to the variable's value. Yes. Okay. Lists. They're all the same. Indexed as list. Index. Yeah, like in Python. Read as element 1, element 2. Yeah. in these square brackets, strings. Why am I even doing this? Well, it's because it's very, in general, like, very automatic to assume. But so strings can be surrounded by this and this. Any customs? Yes, of course, it's an SLA. This is but where it's an SLA. So first one is that true and false default to 0 and 1. This is a huge part. Again, we'll see this later. Which means you can do crazy stuff. Also, this language does not have an and or an or. So since since true is 1 and false is 0, we can replace these concepts. No, I don't. We can replace these concepts. And is a condition 1 plus condition 2 divided by 2. Or is condition 1 divided by 2 is equal to 1. Or is condition 1 plus condition 2 divided by 2 is bigger than 0. Not is condition 1 minus 1 multiplied by negative 1. Also less than or equal is this. It is this instead of this. The better much is counterpart this. Is bigger than or equals. What does this work? Well, as we can see, the conditions sum up to 2 if both are true. So we can get the average in order to determine how many are true. 0 all false, 1 all true, 0.5, 1 true. And then we can set a limit on how much are true. Bigger than 0, at least 1. Equal to 1, all of them. So, and we can do this for any number of conditions. For not, it's simple. 0 equals 1, 1 equals 0. Yes? When we subtract 1. 0 equals minus 1, and 1 equals 0. We subtract 1, yes? So it flips. And then we just flip the negative in order to get 0 equals 1, 1 equals 0. Simple. That's because, again, it doesn't have and or not. What did I just say? And or not. Yeah, it just have it. We need to substitute that, but it's very simple. Again, if you don't understand, I could explain more. Examples. I have some egg. This upon. I have some egg samples. Egg marketing. Okay, it's me, your ex-husband. This is from memes from Delphi. Okay, hello world. This is simple. We just write the string hello world. A truth machine. Right, so this is going to be complicated. Yes. These are all in the code. The truth machine. Go to 3. Go to 5. I'm just reading out the code. Go to 5. Go to 7. Num equals get num 1 or 0. Go to num equals 1 plus num equals 0 divided by 2 is bigger than 0 plus 1. Write error. Go to 14. Go to num equals 1 plus 8. Go to 10. Go to 13. Write 0. Go to 14. Write 1. Go to 12. So, let's see what it does. Okay, so this automatically jumps to the 4th line. 1, 2, 3, 4. Here. It gets a num. Either 1 or a 0. Okay. It wants us to get a num, yes? Number. So then we give it a check. Yes, we go to we go to if the number is equals to 1 plus the number is equals to 0. So if it's either a 1 or a 0, yes, divided by 2 is bigger than 0. So this or the number is 1 or 0 plus 1. Now what this does is basically this is a math expression that returns either 0 or a 1. No, well, Boolean expression, yes, but there's no Booleans. Certainly, this is a number expression. And then we go plus 1, so we go to the 2nd line or the 3rd line. Now, the 2nd line redirects us to false. Yeah, if we false, we go to the 6th line. So 0, 1, 2, 3, 4, 5. We write error and go to the 14th line, which is a shortcut for exiting the program. Since when we do that, we exit the program because there's only 14 lines and the lines start with 0. Yeah. However, if it is a 0 or a 1, we go to the 7th line. 1, 0, 1, 2, 3, 4, 5, 6, 8 minus 1. Okay, so then we check if the number is a 1, and then we go to this plus 8. So if it's a 1, we go to the 9th. If it's not a 1, we go to the 9th line. Wait. We go to the 8th line, indexing with 0, and if it is a 1, we go to the 9th. So 9s and 10s, yeah. So this line is for false. I remember that it directly redirects here. This is the truth machine. If you don't know, wait, I already started. Okay, the truth machine. It's basically when you write 0, it prints out 1 0. Who doesn't know? And when you input 1, it writes an infinite amount of words. Okay, go to 10. So if it is 1, we go to the 10. So we can start from 13. Okay, go to 10. This redirects us here, I remember. And then we exit the program. Else we go to the 13th line. Wait. Why did I go to 12 then? I couldn't just say go to. Well, okay. We go to the 12th line, which redirects us to the first line, and then it gives a command, go to the 12th line. So it infinitely loops. This is very logically heavy, and this is exactly what the man who cancelled GoTo was talking about. The Plutonisa, yeah, I don't remember how it's in. I don't remember how it's in English. Get the Ukrainian version. Now this is the Fizzbuzz. Okay, so what Fizzbuzz does is just basically. Oh, okay. Let me. I don't know how to show it. Okay, Fizzbuzz. Fizzbuzz in English. Explanation. Okay. This is a classic programming challenge. An interview question where a program prints out numbers of 10. However, for multiples of 3, it prints fizz. Instead of numbers, multiples of 5 prints buzz. And for multiples of both, it prints fizzbuzz. Divisible by 3 and 5, we can just take the modulo. This is the modulo. Okay. We can, by the way, here, this is a modulo 5, yeah? So, what the modulo does, who doesn't know, let me click open decimals, is, okay, so it takes, a number, yeah? This is a number. This is the percentage. Oh, I know. We need to get the modulo with this. That's what I was missing. Alright. So the modulo of a number is basically. So until the number. Yeah, as you can see. So the basically is the remainder of the number when divided. So 0 is 0 because 0 divided by 3 is the 0. Yeah, 1 cannot be divisible. 2, yeah, and 3 is divisible by 3, so it's back to 0. we can also substitute this with module by 15. I don't know why it works, but it works. Okay. Okay, so we go to the fourth line as always. We could really just not do it by not doing. Never mind. Okay, so we set I to 0, and then we set I to 1, I plus 1, so it's 1. Okay. Then we go to I is less than, well, equals or less than or equals to 100 plus 1. So basically, else or false or true. If it's false, we just exit the program. This is the 18th line, and if it's true, we go to the 6th line. So the 0, 1, 2, 3, 4, 5, 6. Go to this 6th line, yeah. So if I is divisible, by 3 and 5, this is, yeah. If I by modulo of 15 is equal to 0, if it's divisible by 3 and 5, we go to the next. It's plus 7 here. Okay, wait. 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. Oh, wait. 0, 1, 2, 3, 4, 5, 6, 8 minus 1. Okay, so it's either the 7th or. And yes, I am going to be saying 8 minus 1. I am not going to be saying that number. It either goes to. Okay, so it either goes to this line, or this line. This line. Okay, if it's true, if it's divisible by 3 and 5, we write fizzbuzz and then jump to the 5th line. Basically increment eigen and do this process again. Else we check if it's divisible by 5 and we go to the plus 10. 1, 2, 0, 1, 2, 3, 4, 5, 6, 8 minus 1, 8, 9, 10. We go here and here. If it is, then we go to the 11th line, so the 12th line. And the 12th line is buzz. We write buzz and go to eigen. And else we check if it's divisible by 3 then. Yes. If it's divisible by 3 and go to the 14th or 15th line. Yes, okay. So 1, 2, 3. No. 0, 1, 2, 3, 4, 5, 6, 8 minus 1, 8, 9, 10, 11, 12, 13 or 14. These two redirect us to the next. If it isn't divisible by any of this, we simply write out the number and go to 4. And else we write fizz if it is divisible by 3 and go to 4 again. So this is the explanation. Yes, it's what exactly programmers wanted to avoid with canceling goto. Yet something happened. And yes, there is an actual GitHub to the interpreter, hence the name. Yeah, that's why. There's an interpreter. It was Interpriterlol. By the way, the interpreter is written in Python. Yeah, it's super slow. Okay, it's there's even a Linux. Yeah, okay. Let's read out this. I don't know. I'm planning on adding Windows. Optimized version 1.0. I'm planning on adding Windows, but I'm not installing Windows 10 on my virtual machine. I don't know how I'm going to do that. Microsoft is evil because they want money for an operating system. Like, I already bought a computer. Why do I have an operating system? Yeah. Okay. So there's the shell file. It's basically a an ask file. Yeah, this is just Python 3 file done. Yeah, it is basically checking for the number of arguments, and then it's either going to file done. Yeah. There's tokenizer. There's a list of all of the tokens. Here it is. Comment. There's also comment. Alright. And this is just... You can see it on GitHub, by the way. I will add the GitHub. It's 2% shell, 0.2% shell, and 99.8% Python. The file done basically executes a file. Drawing.png. This is the drawing you saw in the intro. It is included. License. This is my own license. I'm not going to read it out, but many ones will probably want it. That's what AI said. I mean, this is just personalized for me. I don't care. These are the tests. I wrote this wiki page by myself, by the way. These are the tests. This is basically the FizzBuzz program. Yes. They have an extension. Although I haven't really implemented any extensions. They're just with extension.io. Because I want some, but you can really feed them any. Oh, it looks like my headphones are on, but I don't care. Hello.io. Yeah, this. Oh no, wait. This is this is just a test. It's not Hello World. Go to the 7. Go to 3. Go to 5. Oh yeah, we go to the 8. Oh, cool. We can check them. Alright. Oh, what is this? Well, no. Okay, no. Go to 7. Go to 3. Go to 5. Right? You know. Okay. So we go to the 7th. Let me do this the easy way. We get the number. If it is equal to 1, go to 1 plus. If it is not equal to 1, you go to the first line. So your number is not 1. It means your number is not 1, and then exits the program. If it's 5, if it is, it writes your number is 1 and exits the program. This is simple shit. Yep. I haven't made any documentation for this. About some description, website that is provided. License. Oh yeah, this goes here. Activity. What's activity? Oh, these are mine. Why am I going through this? All right. I wanted also to show you how it's actually done. Projects. Go to projects. Labyrinth. No, wait, not this. My languages. Interpriterlol. It has a check mark here. So it's done basically. We have folder bin here. Yep. So we can actually test this out. Test hello.io. Test hello.io. Hello FizzBuzz.io. Yep. Let's do not this. Okay. I can. Let's find the folder bin. Fold.bin. Tests. At there's also full.py. I just put all the files in a single file and then made it. I can't even show you. I can even show you. Why am I explaining this? I can even show you. Yeah, there we go. This is just the interpriterlol.sh but in Python. It's literally the same code. But anyways, so I want to show you. Go to FizzBuzz. Let's do FizzBuzz. FizzBuzz.il. What about this? Yep, it prints out FizzBuzz. Yeah, it's a little bit slow, like takes a second, literally. But it's here. 1.0, 2.0, and it prints it out correctly. I tested myself, yes. Fizz 4.0, Buzz, Fizz, yeah. Fizz, Buzz, Fizz, Buzz, 14, Fizz, Buzz. Yeah, okay. It's so let's test out hello.io. Hello. Oh, I'm not here. My number is what? Your number is what? Your number? Yeah, my number. No, yeah, my number. Number 0. Number isn't what. Now let's do what is. How do I call it? A truth machine. Okay, but with an underscore. Machine.io. 1 or 0, yeah, just for. It prints 8 number, by the way. Anyways, it prints here. Okay, so if we give 1, it prints now odds. Oh, by the way, I don't know why it does this, but apparently it gives the. When I Control C, it on Linux, it gives the. It gives the Python. It shouldn't do that. I compiled it with Nutica, but it gives us a Python error. But I don't care. Alright, and if I print 0, it just gives us a 0 and quits the program. And again, how I said. Now onto the technical stuff. If you want, you can just skip it. All numbers, yes, this is actually called a number. Are floats by default. So if you do anything with, and they are stored as lines in the tokens. So if you want to, if you need to do, no wait, if you make any math operation with a number, it will come out as it will come out as 0.0 if you're not adding any floats to it. And if you leave it be, but without a .0, it will come out as the number you've written. So it's very inefficient, or I don't know. Well, also, yeah, this is Ragix for the number, by the way. You can use it. So, what else? What else did I want to? Oh yeah, there's also concatenation here. Oh wait, yeah, this. Wait, this is execute tokenizer. Where's BT? This is not. Exec. No wait, it's here. Even. Wait, this is. No wait, this is tokens. Where is the line? Stop. Pops BT. Oh, exactly here. Now the cool thing about this is there is actually if this is all the operations. Okay, so if type of A is string, okay, this is just to okay. If string, there are actually a few. We can actually also do operations. We can concatenate with a plus. We can equals not equals. We can also do that with lists. Oh, and by the way, if it's a float, we can multiply strings by floats. There's also lists. Yeah, we can do all the same things. What I was gonna show you. I can also show you. Yeah. Okay. Let's file done. No, that's file done. Percentage here. I also want to show you all the errors this programming language has and how are they expressed. So this is really not telling of error. When it comes to errors, this programming language is not a language that tells you what exactly the problem is. It just tells you what it got wrong about your code and then leaves you be. It doesn't specify anything at all, just what the problem was. No variable found when there isn't a variable. Incorrect second data type in collection. The incorrect data type is, I believe this was left, yeah, this was left from behind, from my previous version. Nicor, non-passable collection of arguments. The one which triggered the error is, so a collection is when you do math, yep, when you get an error, for example, when you make it 1 plus 3 plus plus, this is 2 plus plus 4. This is 2 arguments, and it expects to have, and it expects you to have number operator, number operator, number operator, operator number, like this. You need to have it like this, or string list, whatever. What I just closed? Anyways, wait, not obvious. Okay. So yeah, and if it does not see it in the right place, or it does not see a value at the end, or it sees a wrong type of value entirely, it will throw Nico at you. With wrong order of collection, this occurred because error has occurred in the wrong place. I believe this is still FPF. Where is it? Okay, woof was. Oh yeah, this is also used. Wait, where is it, Nico? Oh, Nico is 101. Okay, so woof. No, we use woof for this. NCTD, non-compatible data type, which is basically it's when we want to math parsify something that is not math parsifiable. IOO, incompatible operator. This is also from behind, is it? Oh no, there's actually not it. Oh, it's in Lior. Oh, there it is. IOO. Well, it's basically when the operator is not. Okay, so this is. It's still used. IO, incompatible operation. This is, wait. Not in Lior. This is IO. You know, it's just IO. I don't know where it's making. CS cannot set error to but what is this? Oh wait, is it? Is it in the? Yeah, it's when it's for example, it gives me the type. So cannot set a number or cannot set okay. CRNRVV cannot reset non-reference variable value. This is when you, for example, want to a equal. This, for example, when a equals to 0. Wait, what is it doing? Oh. This is by the way the divider. You can make one line. To functions. Yeah, and to separate this being 0 and the function right set to a, and to be 0 set to a and right something, you do this if you want to do it in one line, but this will not count as a line when going to go to, so it counts only real lines that are in the code. So okay, this and then you set a, and then you want to do this, you get this error because a is not a reference. It cannot reset a reference variable because it's not a reference variable. Variable value. ICL incompatible collection length. I believe this is yeah, it's only used in one place. Where the last one isn't a number, it's an operator. This is only used in one place. You know what? Incorrect number of arguments. Pretty simple. It's when number of arguments, so it's basically default 1. It's basically when the number of arguments is wrong. So if you have 2 arguments or 0 arguments, it will give you what. GFNE, go to fractional number exception. It's when you put a fractional number into go to. IFNE, index fractional number exception. It's when you put a fractional number into index. And PQA, no possible collection of arguments. I'm pretty sure this is. Yep. This is just when a set is in a number of a set reference. Yeah, but basically all the stuff that shouldn't go here. All the stuff that shouldn't go. Your list index out of range. It's when the list index you set is out of range. Undefined function. It's when the function you wrote, for example, ABCD, is not a function. Yep. So this will give you undefined function and the function. UCB unmatched closing bracket, unmatched closing bracket. UOP unmatched opening bracket, unmatched opening bracket. Nan, not a number. It's just not a number. But when it's not yeah, if it's not a number, it is a number. Get num. It's using get num. Yeah, when it's not a number, it's also used. Not here. Not here. This is all. Not a number, yeah. CBS for not. Cannot binary shift a fractional number of times. Self-explanatory. Binary shift is basically when, for example, we have a 2. The 2 in binary is, let's say there's 4 registers here. 0, 0, 1, 0 is second here, and 3 is 0, 0, 0. And if we binary shift it by 1, it's basically going to be so 4. Binary shifting by 1 is, yeah, and if we binary shift by 2, it's going to 2 places. And also, if this is what happens if it's 3, it's this is 16 plus 8. 16 plus, yeah, okay. So you understand, yes? Oh no, wait, this is 8 plus 4. 8 plus 4 is okay. So this is 12. 2 binary shifted by 2 is 12. No, 3 binary shifted by 2 is 12. Okay. So cannot binary shift a fraction number of times. 2 binary shifted by 2 is 8. And in case it's nothing, it's actually nothing, this won't happen ever if you don't if it the thing that is in here doesn't happen. But if it's nothing, it will say this program has suffered major brain damage. Which is true. Here's my test. These are my tests. Yes, okay. So this is the main thing about Interpriterlol. It's a very go-to based language. It uses a lot of go-tos. You cannot live with go-tos without go-tos. That's the main esolanchiary thing of it. Now I am planning on adding. I am planning on adding something. I'm planning on adding new syntax, which will make it less esolangy, but still. So see you until then. Bye.